Hello, I'm Jay Buckley, Technical Training Manager at Honeywell Consumer Products Group. Welcome to Module 1 of the 2011 Autolite Challenge Professional Technician Program. This module will focus on spark-ignited direct injection, or SIDI. We'll begin with a little bit of history. From there, we'll explore how the systems and components work. We'll discuss advantages and important features. And we'll cover diagnostics, service procedures, and technical tips. You'll gain the skills and learn the safety precautions required to perform different service procedures that are important for completing diagnostics and service on this high-tech system. The first use of direct fuel injection was on the Hesselmann engine invented by Swedish engineer Jonas Hesselmann in 1925. Hesselmann engines used the ultra-lean burn principle. This injected the fuel in the end of the compression stroke and then ignited it with a spark plug. It was often started on gasoline and then switched over to run on diesel or kerosene. The Hesselmann engine was a low compression design constructed to run on heavy fuel oils. During World War II, both German and Soviet production aircraft designs employed gasoline SIDI. In 1952, Bosch developed the first automotive direct injection system to run on gasoline. This system was introduced by Goliath and Gutrod the same year. The 1955 Mercedes-Benz 300 SL became the first sports car to use direct fuel injection. The Bosch fuel injectors were placed into the bores on the cylinder wall used by the spark plugs in other Mercedes-Benz six-cylinder engines. The spark plugs were relocated to the cylinder head. It was all mechanical and a very expensive design. During the late 1970s, the Ford Motor Company developed a stratified charge engine they called Proco, or program combustion. But it wasn't until 1996 that gasoline direct injection reappeared in the automotive market. Mitsubishi was the first with a GDI engine in the Japanese market. In the late 1990s, Toyota's D4 direct injection system first appeared on various Japanese market vehicles. In 2000, the Volkswagen Group introduced its gasoline direct injection engine. And in 2001, Ford introduced its first European Ford engine to use direct injection technology, which was badged as SCI, or Smart Charge Injection, for the direct injection spark ignition. This included some turbocharged derivatives, including the 1.1-liter three-cylinder turbocharged unit. In 2003, BMW introduced a low-pressure gasoline direct injection V12. Since 2004, General Motors has released 3 direct injected engines in the United States, including this 182 horsepower version of the 2.4-liter EcoTec. In 2007, Ford introduced its new Ford EcoBoost engine technology, designed for a range of global vehicles from small cars to large trucks. You can go online and find many more details in the vast history of these systems. The main takeaway is that automotive technology is always changing. Why? Because of the 3 major challenges that automotive engineers face: performance, fuel economy, and emissions controls, and how changing one affects the others. Performance engines produce a lot of power, but they also produce dangerous emissions and have poor fuel economy. Cars with great fuel economy have very poor performance and typically have lean combustion, which produces high nitrous oxide exhaust. If we control lean exhaust by adding fuel, then fuel economy will suffer. Today we have the technology to squeeze out additional horsepower and increase fuel economy while keeping exhaust emissions low in a traditional internal combustion engine. When we compare different systems, direct injection has several major benefits: better fuel economy, especially on turbocharged engines, higher compression leading to increased horsepower, and lower emissions, especially at startup and warm-up. In a nutshell, carburetors, throttle body injection, and port fuel injection systems spray gasoline at a distance from the combustion chamber. The atomized fuel separates from the air, liquefies, and sticks to the walls of the intake manifold, especially on a cold start or warm-up, which increases emissions. With direct injection, the gasoline is precisely metered and sprayed right around the spark plug. Nothing is wasted or dripping down into the oil. Now we'll take a look at how the direct injection system works. It all begins in the fuel tank. There you have a pretty standard modular returnless fuel pump and stainless steel lines pressurized to 60 psi. I can remember when 60 psi was considered high pressure, especially right after throttle body injection, which only had 9 to 13 psi. You also have a stainless steel pipe containing the fuel pulse dampener and the fuel pressure service port. That's where you can check the fuel pressure using a standard gauge. The dampener connects the fuel line to the high pressure pump. It helps to reduce the clicking sound from the pumping pulse action of the high pressure fuel pump. This is where the low pressure ends and the high pressure begins. Now check this out. The high side starts at the high pressure pump, which is located at the rear of the cylinder head. It's driven by an extra lobe on the camshaft. This pump is capable of delivering fuel up to a pressure of over 2100 psi. Now that's a lot of pressure, about the same as my pressure washer. This is where you might need a face shield. The high pressure pump incorporates the fuel rail pressure regulator, or FRP. The FRP is operated by the ECM using pulse width modulation to regulate from about 500 psi at idle, increasing to over 2100 psi for acceleration and performance under load. The high pressure pump also incorporates a pressure relief valve. Of course, most of us don't have a pressure gauge that goes to 2500 psi. So how do we test that kind of pressure? We'll come back to that later on. The high pressure fuel goes to the fuel rail and it delivers fuel from the pump to the injectors. A fuel pressure sensor is attached to the fuel rail and it contains a diaphragm and a strain gauge. Both the fuel rail and the pressure sensor are made of stainless steel. A silicone-free lubricant, like a drop of clean engine oil, should be used before mounting the sensor. Mounted to the cylinder head, the electromagnetic fuel injectors spray fuel directly into and around the spark plug in the combustion chamber. Precision machined holes generate a cone-shaped spray pattern. The injector hold-down clamp must be replaced if removed because the clamp gets distorted when it pushes down on the injector. The ECM converter steps up the voltage from 12 volts to 65 volts and charges a capacitor. The capacitor provides up to 65 volts to open the injector under high pressure. Then the ECM provides a pulse width modulated 12 volts to hold the injector open for the programmed on time. Now we'll talk about service procedures and technical tips. Safety is always first. The system could hold the high side pressure for more than 2 hours. So before any service can be done, you have to depressurize the system or it can cause serious injury. As always, be extremely careful when using flammable materials such as gasoline. The pressure is very high. Follow all shop safety procedures. Wear your safety gear and always have a fire extinguisher available. Low side system pressure relief is the same as with standard fuel injection systems. With the key off and fuel pump relay removed, use the pressure gauge valve and depressurize the low side. High side system pressure relief can be done two ways. Shut the engine off and wait at least 2 hours. Then cover the high pressure fitting with a shop towel and loosen. Or use the scanner to command the fuel pump relay off or take it out. Then run the engine until it stops. Turn off the ignition and use the scan tool to confirm that the fuel pressure is dropped to 0. With a factory-capable scan tool, you can do the following: fuel pump on and off, fuel system high pressure reduction, fuel pressure control, fuel injector balance, and cylinder power balance. Okay, now that it's depressurized and diagnosed, we can take the injectors out. Well, actually not quite yet. Let me show you another tool I think you'll like. The active fuel injector tester unit can be used to diagnose fuel system related conditions such as crank, no start, hard start, misfire codes, injector wiring codes, bank lean or rich codes, and power loss. It also works on Duramax diesel engines. Current service information requires manual calculation and interpretation of the results to reach a diagnosis. This tool automates the process and provides accurate, reliable information about all the elements of the fuel injection system. All the measurements and calculations occur automatically, giving you an accurate diagnosis and saving time. Let's see how it's done. When prompted, the technician cranks the engine on the AFIT. Then the tool stops the cranking, and after each crank, one of the vehicle's injectors is tested. The fuel pumps, starting system, and regulator are also tested for proper operation. When the test is complete, the results are displayed on the AFIT main unit in a format that's similar to the results screen for a port injection vehicle. While cranking the engine, the tool measures battery voltage and cranking RPM and then compares those results to specifications for the vehicle. The tool determines high pressure pump characteristics by measuring the fuel pressure developed at various engine speeds during each crank, and then comparing the results to the expected pressure versus RPM built into the tool's database. In addition, it verifies that the low pressure pump is delivering proper pressure to the high pressure pump. This tool also performs a high pressure leak down test to determine if the system can maintain proper pressure and to ensure that it's not leaking. When all the injector tests are completed, the results are displayed on the AFIT main unit screen in both graphical and numeric form, along with vehicle-specific good and bad tolerances for the injectors. The results can also be uploaded to the AFIT upload utility installed on the shop PC. This tool can help technicians pinpoint the component in the fuel system that requires repair, as well as eliminate the fuel system as the cause of a drivability condition. It can also tell you if the fuel system is causing spark plugs to foul, or if it's causing trouble codes like P0300 through 306 or P0171 through 175 and other symptoms that do not set codes. These symptoms can also be caused by a number of faulty electrical or mechanical components. Sometimes you may blame a fouled spark plug as the misfire cause, but it could be that the injector is fouling the spark plug. Until you correct the root cause of spark plug fouling, you can't correct the misfire DTCs. You will also need some practice to diagnose these engines. Now we can remove the injectors. To remove them on a high mileage vehicle, you may need an injector puller and special tools to clean off the carbon that has accumulated through the years. This engine is new, so we won't have that problem. When removing injectors, the following must be discarded and replaced: the fuel injector hold-down clamps, the O-rings, the plastic spacers, and the fuel injector seal. The Teflon seal on the tip of the fuel injector must be installed and sized using special tools. Details are in your service manual. Now let's look at the special procedures needed for the high pressure pump. Remember, the system must be depressurized first. When removing the high pressure fuel pump, the following must be discarded and replaced: the fuel pump bolts, the fuel pump gasket and O-ring, and the high pressure fuel pipe between the high pressure pump and the injector rail. When installing the high pressure fuel pump, be sure that the roller lifter is oriented properly. The camshaft is on the base circle and the number 1 piston is at top dead center on the exhaust stroke. The technology behind spark-ignited direct ignition has a very rich history. It is constantly evolving to meet the challenges of engine performance, fuel economy, and emissions. This is a technology you'll be working on more and more. In fact, it won't be long before almost every engine you work on has direct fuel injection. Thank you for your time.